these people here, they have no idea why it is happening to them. And what's happening is global warming. But I've always wanted to be a part of the change that ensures a better future for them. But the question is, why is it all happening? And to answer that, I'll give you an example where our Earth went to a doctor, and with the symptoms of all the tsunamis and flooding and all that, and the doctor diagnosed it with global warming, and it tells it that okay, these are your reasons for high temperatures these days. But what is global warming? And one of the culprits for global warming is the greenhouse gases. And one of the gases that I like to turn your attention to is carbon dioxide. What it does is it entraps more heat than it is supposed to, and thus rising the global Earth temperature. So what we want to naturally do is get rid of this carbon dioxide and cut our global carbon dioxide emissions. But we can't do that really, because we still have a lot of industries in place which are generating carbon dioxide at an enormous rate. So how are we trying to solve this problem in this day and age? Apparently, this is how we are solving a global issue, which is that all the carbon dioxide that is coming from the industries, it is getting stored underground. And it seems like we are trying to get rid of it, and we are afraid of dealing with it. Rather than using this carbon dioxide, we are just getting rid of it in underground reservoirs. But if we look at it, the carbon dioxide could be converted into very useful products, such as methane, which is natural gas, formic acid, ethylene, or others. So we can think of this carbon dioxide as a very important source. So how can we convert this carbon dioxide into these products that we have mentioned? So at the center of this conversion lies a catalyst, which can let us go from a world that is polluted and dark to the green and clean world. So one of the catalysts that I like to turn your attention to is the MOFs, or the metal organic catalysts. And what I want you to remember about these catalysts is just the name, and you'll get everything about it. So it is an organic catalyst which has metal sides and is organized in a beautiful decorative framework. How do we make this catalyst? It's like making a building. We make a building brick by brick. We make this catalyst chain by chain. So we have an organic chain, and we join the chains using a metal joint. And then we join the chains to get our final MOF structures. But why am I so enthusiastic about these materials, and what is so great about these materials? One of the properties that I like to mention here is the surface area. Imagine how big a football field is. With just 1 teaspoon of these material, we can cover an entire football field. That's how enormous their surface area is. But it's not just about the surface area. It has other properties as well. For example, one of it is the porosity. And it has open porosity, which means that it gives access to gases like carbon dioxide, which can come at any part of this catalyst and get reacted and converted into the products that we want. Another important property about these materials is that they can be tuned on demand. So we can change the structure whenever we want to. We are not getting the results that we want. Okay, we can change the structure. So imagine a Rubik's Cube and imagine immense number of possibilities. That's how these structures work. So this is the structure that we have developed here. And the great thing about this structure is that the organic chain in itself is also conductive. And this is a very important property to have when we are doing electrochemistry. This is not usually the case. Of course, we wanted to claim that we actually made the structure and not just big talk. So we did some analysis. Here is one of them, which proves that we have nitrogen, carbon, and copper in our structure, thus proving that we actually have got what we are saying. If we go further, interestingly, we found out that in our structure, all the atoms are aligned in a single crystal plane. This is a very important property, because if our atoms are aligned in a single crystal plane, they can be easily manipulated, and we can achieve other planes. But the question is, do they actually work? Do these materials actually work? The answer is yes. And we have tested them for carbon dioxide reduction, and to get products such as methane and ethylene and carbon monoxide. So yes, these materials absolutely do work. But is that it? No, these materials have various other applications, for example, in hydrogen generation. So as you know, hydrogen is a very important upcoming fuel, and it is a clean and green fuel. The important thing is how we do it. So what we do is that we have water, and we want to split out the hydrogen molecules from the water. And how do we do it? Again, we use these structures, which in an electrochemical environment, we can easily extract the hydrogen molecules from water. And still, interestingly enough, they have other applications as well. For example, in biomedicine, energy, packaging, and whatnot. You just name an industry, and these materials will have an application in that. And finally, I would like to conclude by saying that if you have anything related to material science, to electrochemistry, organic chemistry, renewable energy, hydrogen formation, carbon dioxide reduction, better call Zubair. Thank you. That would be all.